Welcome. We're going to get started, and we're going to talk about some buzzwords and some microservices and event-driven architecture with Apache Kafka on Heroku. But first, we have to do the forward-looking statement slide. How many of you have not seen this before? Yeah, right. Make decisions based off of publicly available services and products. OK, why are we here? I would posit that one of the main reasons you are here is because of anxiety. How many of you have to make architectural decisions for your company, for the systems that they're building? OK? OK, almost everybody, a good amount. How many of you have anxiety about making the right decisions in that architecture so that it scales or grows whichever way the business is growing? Yeah. I do too. I mean, I feel that anxiety, and I'm a developer advocate. I don't push anything into production. I just make demos, but I still have anxiety about choosing the right architecture, right? But let's talk about the definitions of these two words first, just to make sure everybody's on the same page. So we're going to talk about monoliths and microservices. Monolith being something that is a single deployed application, generally from a single code base. A microservice being a set of services that are deployed independently, also generally in different code bases. But if you were to go to Wikipedia like we did to do some research for our talk, you would find this. There's no industry consensus on the definition of what microservices means. It's just a buzzword, right? So we're going to not focus on defining what microservices are or making a perfect definition for you. We're going to share how to think about them, when to use them, when not to use them, what benefits they give you, and what costs they have associated with them. But first, some introductions. I'm Chris Castle. I'm a developer advocate for Heroku. And I don't know, I like biking, I like skiing as just a little personal bit about me. And I'll let Ryan introduce himself.
Afternoon, everyone. I'm Ryan Townsend. I'm the CTO of a company called Shift Commerce. We're based in England. And we build a large-scale e-commerce platform. So we've been moving over to more of a microservice architecture for a couple of years now. So we've had a lot of experience in this area. So we've only got 20 minutes for this talk. Me and Chris tend to ramble on a little bit. Last year we had 40, so we could go a lot further. But this year we only have 20, so we don't have any time for questions on stage. Our Twitter handles are in the corner of the slide, so feel free to ping us any questions. And then after the talk, we can either chat to you guys down here, or the Heroku stand is just behind. So we'll be hanging out there as well, so come and ask us anything at that point. So if you've heard of microservices, just even the word, you've probably seen the kind of hype around it, and that's what we're trying to cut through today. And I think a lot of the hype has been driven out of the fact that you hear about all these really cool, large-scale companies doing microservices, and you're like, oh, well, maybe we should do it. Obviously, they're operating at a very different scale to everyone else, but it's one of those concerns that we see, oh, this looks really cool. But the downside is, we never really hear about the failures. No one's going to post online, or very few people post online, oh, we had tried to adopt microservices and it just went horribly wrong. So you're kind of seeing this tinted vision of what microservices are actually like. But there are some real benefits to using them. So avoiding all the kind of marketing speak around them, I want to cover that off now. So there's kind of three major aspects to what makes microservices beneficial. The first one is the fact that you have really strong boundaries between different modules. Within a monolithic application, you can write your code as modular as you want, but there's always this kind of blurred lines. You've got some code libraries, maybe using a package management system, something like NPM in JavaScript or Ruby gems in Ruby, and there's one in every single different language. And you can't be using all these different versions of the same package, so you end up being dependent between two different areas of your system on this one version of this one package. Also, when it goes into production, there's all manner of other things. You can get crosstalk between these things. They might all be dependent on the same database, so you've got one team having to notify other teams that they're changing an area and all this kind of stuff. And if something goes wrong, you can't really tie it back very easily to a specific person or team. You have to do a real deep dive on who do we alert? We don't really know. So with microservices, you're guaranteeing that these things are going to be completely separate, and you can actually deploy them all independently. So that leads me on to the next point, where each release cycle can be specific to each application. So you might have a load of red tape around a very risk-heavy part of your system. There might be a load of governance and process around getting a release out. You have to do extensive QA, loads of user acceptance testing, that kind of stuff. But you don't want to drag down the productivity of other areas where it's just like, oh, well, this is just like a HTML page. You don't want to slow that down just because you've got this more difficult, more challenging rollout process for another area. So by separating these things out, you can roll them out in their own cycles. And the final one is technology diversity. So you can use the right tool for the job. That might be a really concurrent programming language for something that needs to scale out. It could be something that's really high performance and really low memory overhead. It could be something where you're building a proof of concept and you don't want to use a really low-level language. You want to use something that gets you up and running really quickly, and you're just going to roll it out to a few customers and see how it works. So you want to use something like Ruby on Rails or something more kind of easy and agile to get up and running. And then similarly, you can do all this stuff with your data stores as well. So you could be using NoSQL for some, more traditional SQL databases for others. You can really use the specific technologies that make sense for a given project. And this will also help you with your hiring as well. If you centralize around a given technology or programming language, a framework, then you're limiting yourself to a hiring pool of people who know that stuff. If you can open yourself to other languages and other technologies, then you can actually broaden your hiring in terms of the available talent to you. So if you don't have problems that these things would solve, so if you've not got this heavy governance around particular areas of your application, or if you've got a pretty steady kind of hiring process and you're not struggling to bring on new members of staff, that's completely fine. If you've got a monolith and you don't need these things, stick with your monolith. You don't have to be worried that you're missing out on something, because ultimately there is a price to pay. There are costs attached to using microservices. So again, it's kind of threefold. The first of all is the distribution of that functionality and that data. If you've got two systems that contain their own information and they need to access one another's, it's no longer just making a local call to some code or a database query. You've actually got to go across the network, maybe contacting an API or something like that, in a completely different system that might have completely different performance characteristics, and you can't easily test all that stuff together. So you've got to deal with that. If you are building towards a very modern microservices architecture, you're probably going to have something like an event bus in the middle, and that's something that we'll kind of show off in a bit. So you're going to have this eventual consistency. You've got two systems talking to each other, but they're not immediate real time, because then all manner of things go horribly wrong. They might be a second behind, they might be 10 seconds, a minute, an hour even. Depending on the kind of characteristics of your system, you've got to deal with this somewhere. When someone clicks a button and wants something to be processed, how are you going to action that? And then the final one is the operational complexity. As soon as you move to more than one service, you've got more difficulty around rolling out releases. So you need a really mature DevOps team to be able to run this stuff. And that's where things like Heroku come in and make it a little bit easier. So when it came to writing this talk, me and Chris were looking at how do we minimize these costs? How do we give people these benefits without having to pay all these penalties? So what we've tried to do is mitigate them as much as possible, and the way I'm going to show that is a little demo, so I'm hoping that the Wi-Fi is going to hold out for this. So if I just come out of my slides. So I built this little application. Well, it's actually two applications, completely separate, running on Heroku. We've got a digital asset management suite where a photographer can upload some wonderful-looking photos, and I can go in here, and I can upload a new image. This is where I'm praying for the Wi-Fi. So I've got this new photo of some mugs, and I can upload that, and it gets processed. Simple. Now I want to give access to that photo to another team, another application. What we have is a product catalog, and there'll be merchandisers building out that catalog, completely separate users, completely separate systems that don't actually know about one another. And yet we want to protect things like you can't trash images that are being used. So if I flip over to the catalog now, I can go and create, I'll bump that up. I can go and create a new product. So you can see that we've now got our mug image. Let's just say mug, and we're going to charge $39 for it. And there we've got our new products. But as I mentioned, these two systems are completely separate. So effectively, someone could go into that digital asset management system and try and delete a photo, and that could be a problem. So what we're doing is we're tracking the usage of photos between these applications. So you can see now this photo that I've just uploaded, I can no longer add that to the trash. So quite a simple use case. When I delete my product or remove the photo, then I can go in and trash this again. So I'm just going to go back to my slides now. So how do we actually solve the kind of three problems when it came to just these applications? The first one was our distribution of this data and this functionality. You could just do point-to-point connections between these two applications. It's only two, so that could work fine. But it doesn't really scale out very well. You end up with this tangling mess of connections between different systems. One might fail, and then suddenly everything collapses because this one's dependent on this one, that's dependent on this one, and you just have this kind of cascading set of failures. And if you're Amazon, it gets to this scale. This is literally the Amazon homepage. Like, if you want to load that, these are all the different services that are involved in running Amazon. So it can become unwieldy. Amazon, obviously, a very mature organization with a load of expertise around engineering, hundreds of thousands of members of staff, so they can handle this, but I would guess that most of us probably can't. I certainly couldn't. So the way that we've handled this within our system, as I mentioned, we've got a digital asset management system, and then we've got a product system. We've put Kafka, an event stream, between the two, and we've separated the consistency concerns. So the digital asset management system is consistent when it comes to its own data. Same thing with the product system. But any data that's flowing between the two will be eventually consistent, and I'll come on to that in a second. But what we've done is we've got these events that get published into the stream. Other systems can pick them up, just like an event bus, and utilize them themselves. They can put it into their own database. So effectively, the digital asset management suite could be completely offline, and our merchandisers can still interact with their product system. There's no outage for them. The website's not gone offline, or they can still produce their catalog. So when it comes to the eventual consistency side of things, we've got this delay. Using Kafka as an asynchronous communication mechanism. So that means you put an event in, and then it might get sent onto another system, and it might be 10 seconds before it actually makes it there. I was praying that during the demo it was going to do it quick enough so you didn't kind of notice, but it is all going through Kafka. So we have this issue of you can send something to trash in the digital asset management system, the photo, you delete it off, but then someone could be in the product system and it's a little bit behind. It hasn't recognized that it's been deleted yet, so someone tries to use that photo and they're like, great, yeah, I've added that to my product. The last thing you want is that image to just disappear because it's been deleted. So what we actually did is we had an untrash action. So it reads the fact that these products are being used, these images are being used by products, and each time it either creates a new usage and then prevents deletion, or if it's already been deleted, it'll just drag it back out of the trash. Obviously, there'll be like a cleanup process every 7 days or something. Hopefully, you'll have no outage or 7-day delay. So it'll catch up in that time. And that's why it's really important that you need something that's chronological, just like Kafka, to produce this stream for you. When it comes to operational complexity, this is where Chris's expertise come in, so I'll hand over to you for that.
Yeah, so operational complexity is one of these problems we want a solution for, and I think the best piece of advice here is to don't try to go big bang. Don't try to go convert everything to microservices, or create an entire large and complex system with microservices right away. Start with your monolith, build it out, understand your domain a little bit, start to break out pieces as you kind of want to extend functionality, add new functionality through microservices, or if you want to convert this big monolith, start to break out pieces individually and start implementing them as microservices. And then there's opportunity cost, right? There's the cost of an engineer is not zero. You're going to have them either, if you have maybe one engineer or two engineers, they're going to be creating, setting up, tuning Kafka or an event stream system like this. Or you could have them focused more on building features that are kind of more impactful to your business or to your customers. Then there's kind of similar to that, there's maturity of engineers. So for instance, a front-end engineer or a mobile app developer are really good at what they do, but they may not have strong expertise with setting up, tuning, configuring, dealing with bugs in Kafka. Heroku has now been offering Kafka as a managed service for a couple years, and has a suite of engineers who are operating Kafka, building it, making sure it stays stable, and making sure it's easy to use for you as an engineer. Like that demo that Ryan showed earlier, if he had to kind of set up his own Kafka cluster and make sure it stayed up and make sure it was tuned and working, it would have taken him much, much longer, like maybe twice or three times as longer just to create that one little demo. And then the last piece is kind of Heroku has always been focused on like making the smoothest, the best like user experience or developer experience with our products, and we've tried to extend that to Kafka to make it a very, very easy tool for developers to use, either from like this web-based dashboard or from a command line interface. And again, kind of abstracting away like a lot of the complexity of Kafka. And so to summarize all that stuff, Ryan talked about distribution, and then the solutions for that being isolating consistency concerns within services, ensuring each service is really like self-sufficient, like having its own database. Ryan also talked about eventual consistency, so handling that via how you design and build the UI, and then using an event stream to manage that, something like Apache Kafka. And then I mentioned briefly their operational complexity, right? So start with that monolith, push it as far as it can go, and then start breaking out services. Don't try to convert it completely over to a microservice architecture. And then also, depend on the expertise of Heroku and think about that opportunity cost of where you're spending money on developer time. And so, Ryan showed like one piece of how an e-commerce or retail system might work or might be implemented, but there's going to be a lot more to that, right? There's going to be stores, and there's going to be fulfillment systems and warehouses and logistics and inventory and all this different stuff. So here's maybe another way to look at what that deeper complexity might look like with an event stream down the middle and different streams built in there. So those might be topics within Kafka. And all of these different services kind of broken out by their function. Like what is their function in the business? Sending messages or producing messages into the event stream, and also listening for specific types of messages out of those streams. And ultimately, right, you don't want to get to this. Again, like Amazon's a very mature organization. I don't know how they manage this. They do somehow. This is a real image, by the way. It was on slides from an Amazon presentation. We want to avoid that, right? And so instead of having all these interconnected, n times n minus 1 over 2 number of connections, we can use that event stream to severely reduce the number of the complexity and number of those connections. And then Ryan's going to talk a little bit about scaling, which you might have noticed we didn't bring up at all.
Yeah, so scaling's quite a tricky one. It's something that you might have heard of as a benefit of microservices. Logic dictates that if you have one system and it's reached its limit with hardware and things like that, that having two of them means that you can then double that. So people often see this, oh, great, I can just flip over and extract all this stuff and end up with 10 services. Now I've got 10 times the amount of power. And whilst that is true, you might actually be surprised how far you can push monolithic applications for a start. Not rewriting your whole application and your whole architecture just to get a bit more scalability might be a far better approach, just to kind of optimize your monolith and grow that further. You've got companies like GitHub, like Shopify and Intercom, serving millions and millions of users, all from monoliths. So, it can go far further than you might think. Don't get kind of caught up in the buzz of, oh, great, this is going to solve all of my scaling concerns. You could end up 2 years down the line of trying to extract this stuff, and you still haven't actually improved anything yet because nothing's live, because the challenge and the overheads of producing this stuff. So we broke our rule for our last slide. We were trying to keep all the slides really, really clean and use all the nice graphics that Salesforce provides. So if there's one slide you want to take a vote of, this is the one. We've got the link to the actual slides so you can get your own copy. But just by way of a summary, monoliths are okay. Don't feel bad if you have one. Microservices aren't a silver bullet that just solve all of your problems magically. There are a lot of trade-offs, but there are a lot of specific benefits that they do bring. Starting with a monolith and building up that maturity in your organization as you learn where to divide things up, and as you build up that kind of DevOps experience, that'll be a journey that you can go on and really develop your organization. And then coupling that with the actual architecture of having a centralized source of truth for your data, so that Kafka running between all your applications will set you up for success. Using a database shared by hundreds of services isn't going to scale, and ultimately you just end up with things falling over. So using something that's specific like Kafka for doing exactly this will set you up for success. And then when it comes to Heroku, it just makes it so easy to use all of this stuff. So you don't have to worry about setting up Kafka yourself or all your applications and configuring them all. Even if you just want a trial, I think it starts at $100 a month for just the base plan of Kafka. So just for a weekend, go and try it out. That's everything. I don't know whether you've got anything to add.
Nope, that's all we got. Take a photo of that if you want more details. You can. That link in the top right there is a link to more detailed talk about all this stuff that we did last year. And that's it. Thanks very much for attending.
Thank you, everyone.